Hey everybody, we're on the second last lesson of geology, and that is the rise of Alberta today. So we're going to take a look at how the mountains formed in Alberta, and BC's pretty close to us. We're also going to talk about volcanoes. All right? Okay, so let's get her started. So the reason why Alberta looks the way that it does, compared to lots of different places in Canada, we have the Rocky Mountains to the west of us, we have the foothills, and then we have the plains. And where Red Deer is we're kind of on the plains, right? If you go a little bit more east of Red Deer, you get close to Saskatchewan, and it is flat. It is flat as the eye can see. But if you go a little west, then you start to see the hill, it gets more bumpy, it gets more rocky, and then you eventually hit the Rocky Mountains. So, how did this happen? There are things called crustal plates, or basically tectonic plates, and we've talked about these before. Tectonic plates and the edges around crustal plates cause the most of the land formations that we see today. Okay, they're now going a bit bigger than Alberta, because we are on this massive tectonic plate called the North American plate. And then there's the ocean plate to the west of us, the Pacific Ocean plate. And that's called the Ring of Fire. Where the Pacific plate and our plate are hitting each other, that is a lot of friction. And that runs all the way down the west coast of Canada, the United States, down into South America. And there's all of these volcanoes that are around the Ring of Fire, out to Hawaii. There's also a lot of earthquake activity. And it's because the two plates are meeting each other. Now, if you think of North America, we are almost like this enormous island. If you think of it, right? Like we are an island, way, way bigger than Australia. But if you think all the way north, all the way south, we're kind of like an island. And everything that lives on this area, with the exception of probably people and some species of animals, kind of got left behind when Pangaea separated. And Pangaea is that supercontinent. So when that supercontinent separated, very, very slowly, the animals could probably swim back and forth or fly, but eventually, over millions and millions of years, the plate separated and there was a sea or an ocean between. So whatever animals were living there, and their ancestors and their ancestors and their ancestors slowly floated away. Now with humans, you might learn about that a little bit later. It's very interesting how humans got to North America. Evolutionarily, our DNA is found in Africa. So an ancestor of us lived in Africa, and that's what spread all over the world. So how did ancient humans get from Africa to Canada? Well, if you're First Nations, you probably had ancestors that crossed this Bering Strait when it froze. And if you're Polynesian, you could have just boated across all of the different islands. So there's two competing ideas as to how North America was populated by humans. Anybody else that's not First Nations or Polynesian were settlers that came over on boats. So a little different. Or sadly, some people weren't settlers, they were slaves. They were brought here against their will. Okay, so here's a good picture of the different plates. The North American plate is this big bad boy right here. And the Pacific plate is this big bad boy. There's another little small plate right there. So all along, I'll put it in dots. The Ring of Fire is where all these plates are meeting. So you have volcanic activity and earthquake activity anywhere those plates meet each other. So if you think of the west coast of the United States and Canada, there's a greater chance of earthquakes there. And if you look over at Japan, look at this. Look at Japan. Like it goes right along the side of Japan. That's why there's so many earthquakes in Japan. No, it doesn't mean there's always going to be volcanoes. And It just means there's a greater chance of volcanoes being there and earthquakes. Okay. All right. So today's lesson is how the mountains formed. Okay. First off, if you think back to ancient Alberta, there was this massive inland ocean. So the first step is that the ocean had to be pushed away. And that was caused by plates colliding. Okay. So over millions of years, ancient plates collided and caused pressure. The pressure caused an uplift of rock. So to start with, the Rocky Mountains weren't jagged. They were just like big hills. So I'll do my best to draw this in a diagram. So two plates kind of smoke into each other, and one plate is going to win. It's going to be more dense, and it's going to start to go over top of the other plate. So you might get something that looks like this. So instead of having this big jagged mountain, it's more like a big rolling hill. Actually, that's bad. Let me try this again. So you might get something that looks like this from the plates are. This is a plate meeting here, and it's going down. It's losing. Okay, so you get like a hill. Now, what does that do? Well, remember, there's a big ocean that was on the other side of this, and what that does over time is it spreads the ocean out. So that ocean goes, and the salt water kind of kills everything, and the ocean becomes more and more shallow. If you think about, like, if you made a deep pool of water and if you dug a hole in the sand and filled it full of water and you shoved it, you would spread it out. Now, over time, the uplift pushed the ocean away. So the ocean, escaped out to other oceans. It just kind of like got a big shove and it was gone. Water was left behind in depressions. Those could be lakes. And the last step was erosion made the big hills jagged as more pressure caused uplift. So the best way to describe this is you would have this massive hill, right? And there's one, like the plate is, maybe that's one plate, and this couple, it's pushing another one down. It's a bad drawing. Okay, so the mountains back then were huge, giant rolling hills. And as the pressure built up, the hill got steeper. And what that did was it caused a depression on one side. So a little bit of the ocean would be left behind. This is like right there, that's like old ocean. But the rest of the ocean spread out and was gone. And over time, wind and especially storms and wind eroded parts of the mountain away. And then you got something that, that's a red pen. And then you got something that was a lot more jagged. So instead of having like a nice uniform rock, you had our mountains, which are irregular and jagged. Now, the plates have stopped kind of pushing into each other, so our mountains aren't going to grow anymore. Other places in the world over millions and millions and millions of years may grow mountains. Erosion over millions and millions and millions of years will slowly weather the mountains, our Rocky Mountains, away. That is so hard to imagine, that wind over millions and millions and millions of years can take away mountains, but it's absolutely true. So you don't have to worry about how this happening in your lifetime. I will be dead. You will be dead. Everybody you know will be dead. Maybe there won't be humans on Earth anymore, but they're all going to, that's the idea of mountains. So if you have plates meeting each other, now it's not like the plates go up like this, but one kind of goes over the other, and you have a rounded hill, and then erosion, look, that's terrible. Erosion makes the mountain a little bit more jagged. Okay, so just a bit of a recap. Okay, during the Cenozoic period, the sea retreated and Alberta took on a form and shape similar to now. Okay, all of the great dinosaurs died out by the end of this period. So by the end of the Cenozoic period, by the end of the Cretaceous period, by the end of that time period, the dinosaurs were no more. And that led to the rise of us, the mammals. Tiny mammals at that time. The mammals were living at the same time of the dinosaurs, but they were outcompeted. The dinosaurs were really fierce. It was a good environment for the dinosaurs and not a good one for mammals. And tomorrow's lesson is going to talk about the rise of the mammals, and a little bit about how glaciers then shaped current Alberta too as well. So that's the end of today's lesson. All you have to do today is to do a quick little Google form, continue working on the geology assignment if you're not quite done. We only have one more day this week, that's tomorrow, and we're going to finish off geology tomorrow.